Something that I kind of overlooked in the last tutorial was actually explaining how this grass spawner works. Consider this kind of a supplementary lesson. You might not want to use this functionality in your own world, but I'm going to quickly explain what it is that I've done in my grass spawner, this object that I place in the world. Where is it here? The field object. Wherever I place it down, it automatically generates based off of the length and width. And I also have this gap that I could include if I wanted to add some more space between things, but I didn't use it in this example right now. So what I've done is you can make sense of the variables yourselves, but I have attached the game object grass to this. And when I start, what I have my code do is generalize the length and width of my game object. So I'm going to gather the collider from this grass and store it, and then I'm going to access the local scale of the X and Z axes for the length and width. What this allows me to do is actually change the prefab if I want to. I can go into my prefabs and resize this to be whatever scale I want, and my code will automatically update the length and the width of this new scaling as needed. I don't care about the Y because I'm placing it on the X and Z axis. The Y doesn't really matter. It can be as tall as it wants to be. Now I have these debugs for some testing I was doing. I'm just going to remove them right now to clean my code up a little bit. I don't think I need those anymore. And once I've gathered the length and the width, I generate my field. And here's how I do this in a generalized way as well. I need to figure out how many blocks will fit in the length and the width that I have defined. So I divide the total field length by the length I've calculated of the block and cast it to an int. So it rounds down so that I know the total number that will fit. And if this number is, if let's say like the field length is smaller than the block size, that will round down to 0. I can't obviously fit a block in a field that's not big enough to support it. So this calculation gives me the exact right number of blocks to properly fit inside of whatever dimensions I've supplied. I've also just written a bit of a vector 3 to reference a little bit more easily, so I don't have to type this out over and over again. This is very much optional. And now what I've done is a nested for loop. The idea of making a 2-dimensional array. Because the reality is, oops, I typoed there. In my program, when this grass is spawned, it is a 2-dimensional set of objects. It has one dimension and another dimension of objects being placed. And how do I place these also nicely tight to one another so easily? Well, it's with this for loop. I want to place the number of blocks for the length and the number of blocks for the width. This nested for loop enables me to place both dimensions of blocks. And then I'm going to customize the X, Y, and Z positions. The Y is simple. It's just the same Y position as the actual grass spawner or the object it's attached to. So here, my initial positions are based off of the position of this field object, wherever I place it in the world. So the Y is going to stay the same. However, for every object, the X is going to be related to the initial position, but I'm also shifting it over by how many objects I placed in the length so far, times by the size or the length of that object. This guarantees that they're exactly precisely spaced lengthwise as many times as I defined for the number of length blocks, and the same thing for the width blocks. My Z position or the width dimension in this scenario is going to be the original width position, but with this offset of however many blocks I've generated times by the width of each block, which guarantees the other dimension is all created. And then I simply instantiate a copy of block at this new set of coordinates that I've generated with the original rotation so that everything lines up really nicely. And through the script, I'm able to create as big a generated grass field as I want. And let's just put this to the test for a sec. Let's toss this over here and put in 200. Now this might get kind of laggy. We'll see how good my computer is here. 200 by 200, and I press run, and we'll see how this goes at generating a massive number of objects. And let's look at my scene view. Oh yeah, it's lagging big time. This is awesome. But back in my scene view, I see that I have this massive field of grass, and you can imagine how much processing is needed to actually calculate the collisions here. So this is not a strategy I'm going to use to create all the grass for my scene. Grass needs to be a lot simpler if it's going to fill a massive area. But for this smaller scenario where I'm having it, I want like a decent amount of objects so that it feels really cool when I'm performing the functionality of this scene in the way that it's been working previously. And so I think this is like the right amount to generate. Let's see if I fit it in properly. If it pops in the wall, it's going to slide. There we go. So yeah, I generated enough. That is a cool effect going on. And now you know the strategy for generating massive numbers of objects in a kind of a two-dimensional grid on your own. You can just follow the pattern of logic that I've used here. So I thought I'd fill you in on that before moving on to the next section.